Hi, my name is David Simpson. I'm here with Gregg Lippa. We're both instructors for Themis. I deal largely in the database curriculum, and Gregg is our lead developer and instructor on the Java side. So we're here to talk today about a problem or a question that comes up an awful lot on the database side of our curriculum, and that is the SQL that we write in some of our object-oriented languages like Java. How does that work its way into those applications, and then how do we tune it and so on? So I get asked a lot, or I get complained to a lot by DBAs. I go talk to a developer about this poorly written piece of SQL, or I have a change that I want them to make, and sometimes they don't even know where to find it, right? Because it's not necessarily SQL that the developer wrote anymore. It's being written by something like Hibernate or something on the back end to help me deal with that object relational mapping thing. So maybe we could talk a little bit about what is object relational mapping, what's the need for it, and then why do I end up with SQL that I didn't even write?
Yeah. Well, David, object relational mapping has been a real saving grace for Java developers because it saves us from having to write a lot of SQL. So there's benefits there, but there's also issues. The benefits are it makes the development go quicker. The issues are maybe the SQL isn't always the best. But there are solutions for those issues, and developers don't always know about them. The problem is that the relational model and the object-oriented programming model don't exactly come together. And so tools like Hibernate and many others like Oracle's TopLink have helped to solve that problem by providing automated ways to link basically a row in a table to an object in a Java development environment.
Right, so the object data that we develop in an object-oriented world is not really structured the same way as it is in a relational database. And that's kind of our core problem that products like Hibernate and JPA right now will solve.
JPA, Java Persistence API, is the relatively new standard that's part of Java, the part of the Java specification now, that says tools like Hibernate and TopLink are now able to support a standardized approach within Java to this object relational mapping problem.
So a question a DBA like me might ask is, why do you need this? Why can't you just write your SQL, like I used to do?
Yeah, right.
So what benefit does that provide?
Well, what happens is the Java developer gets to write regular object-oriented code in the form of objects and write code that says things like update and have the framework like Hibernate with its persistence manager automatically generate the SQL to do those updates. Right. The thing about generating SQL is some developers are really good at it and some are not as good. And Hibernate takes the best practices of how to, for instance, if you're doing an update, you want to minimize the locks by doing the update as close as possible to the commit. Well, Hibernate saves up all the updates that you do within a transaction until you do a commit. And then it generates the update statements at that point to do all the updates and then commit.
Right, and so you're hopefully dealing with fewer locks in your database, holding them for less duration or less
contention.
Time. Yeah. So there's obviously some benefit there. There's also some benefit in the amount of time it takes to code and test an application, right, which in a test-driven development environment can be huge, right?
Absolutely.
Yeah.
Now JPA, Java Persistence API, is the generic. Hibernate is one of the specifics. It actually implements that specification. And with JPA, you get the benefit of tooling, where tools like Eclipse and RAD give you GUI tools, graphical tools, to allow you to basically click options and generate the classes that are going to map to these tables in the database.
Right, so it gives you a way to kind of visually link up what's in your objects with what columns on tables and things like that.
And very sophisticated. It supports one-to-many relationships and
right,
foreign key relationships in very, very advanced ways.
So if you're data in an object comes from 4 or 5 different tables, we hope it's generating the appropriate join to facilitate that.
Right.
When you go get the data.
When you go get the data. And it also involves practices like lazy fetching, where it doesn't go and get all the data right up front, but waits until you actually need it, just in case.
In case you don't need it.
In case you don't need it.
Right. So how much control then do we have over the SQL that gets generated? So if it generates a statement that's a poor performer, if I as a DBA see something running poorly on the back end, can I come to you then and say, fix this?
That's a good point. You have a lot more control than a lot of people think as far as how much control over the SQL, because there are hooks in Hibernate that allow you to replace what would automatically be generated with your own SQL statements.
With an optimized statement.
Exactly.
For the platform that you're working on. And sometimes that's key, right? Because the statement that runs well on Oracle may not run well on DB2 or vice versa. So we may want to play with it based on the platform, the target platform that we're actually working with.
Yeah.
Where Hibernate's generic, right? It can accommodate any platform on the back end.
That's right.
Yeah.
You just have a different driver that connects to the appropriate database.
Right. So we said one of the benefits of using something like Hibernate is speeding up development time. We can work in an object-oriented world. So when would I choose to use Hibernate versus not? And I think maybe one of the things we've talked about is, how complex is the SQL? Am I working on a transactional system or something that's more like a reporting or data warehouse system where the SQL is going to be really complex and maybe more difficult for Hibernate to get right the first time?
That's true. Hibernate is really good at transactional systems and doing the updating. It's good at fetching as well, but the more you write complex queries, Hibernate has the tools. You can build any query you want, give it a name, store it either in an XML file or write in the Java code and invoke that query. So it has the capabilities. It's really a matter of whether it's the best tool for the job. That may not always be the case, but it usually is.
Right. Okay, so one of the classes that we have that talks about this in some detail is what we're affectionately calling Java for DBAs. The full title is something like what DBAs need to know about Java and object-oriented development. You talk about this in some detail, right? How did we as DBAs need to be looking at Java and understanding that object relational mapping and dealing with how the driver is going to deal with that and those kind of things. Right?
That's right. That's a 4-day class that gets into really basic OO as well as some Java and Java Enterprise, even a little bit of EJBs as far as transactionality, a little bit of security. But one of the things that's generated the most interest when I've taught that class has been the Hibernate side and the ORM. So
right. And that's, I think, just a pain point for a lot of us dealing with performance. So I think one of the trade-offs that you're dealing with Hibernate is, the cost of development time versus the cost of running the queries on the back end, and how optimized do I want that to be.
Yep.
So that class is a real good one for kind of digging into these topics a little bit more, and hope to see you in one of those soon.